Alright, so in the previous video, we were introduced with what is a photon and we went over electromagnetic radiation. Now, in this video, we're going to be going over the second aspect of this chapter and we're going to be focusing on the photoelectric effect. Alright, so what is the photoelectric effect and what properties are associated with it? What observations we can conclude from this effect? And much more are going to be covered in this section. All right. So right here I have two diagrams, and the one which you guys would be most familiar with would be this one. And this is the basic concept of photoelectric effect. Now what happens is this is a metal surface, and on a metal surface you project electromagnetic radiation. So electromagnetic radiation is illuminated onto the metal surface, and we know that electromagnetic radiation contains photons, and a photon is a small packet of energy of electromagnetic radiation. So when this electromagnetic radiation strikes the metal surface, electrons are emitted off of the metal surface. Now, why is that? Because in the metal surface we have free electrons. Free electrons absorb the energy of the photon, and the relation is a one-to-one relation between one electron and one photon. So what happens is one photon transfers its energy to one electron, and the energy of the photon becomes the maximum kinetic energy of the electron. Hence, this gives it enough energy to escape from the metal surface. Now let's go over the reasonings over here. So yeah, this is because each photon from electromagnetic radiation passes off its energy to each electron in the metal, and the state of energy in the electron is the maximum kinetic energy of it. Alright, the electron absorbs this energy and enters an excited state, hence the electron leaves the metal surface. Alright, these were the reasons. Now, this was just the basic concept. Now, this circuit is a practical application of this concept. You might not see this circuit everywhere, but the examiner might hit you with one of these, as they did in May June 25, where they gave this diagram and told the candidates to give their observations and what's working in this and what not with some graphs. Okay, so what happens here is that this is our metal plate, and electromagnetic radiation is incident on this metal plate, which forces electrons to be emitted off of this plate. Here, electrons are absorbed, and this circuit continues to flow. This is how this circuit is working, and it's just a practical application of this diagram. All right. So the basic summary of this experiment is that when electromagnetic radiation is incident on a metal surface, electrons are emitted off of the surface. This is known as photoelectric emission or photoelectric effect. All right. Now, before we move on to the observations of this experiment, we're going to be focusing on a few key terms. First of all is our threshold frequency. Now, what is our threshold frequency? Our threshold frequency is the minimum amount of frequency a radiation must have in order to carry out photoelectric emission. Below this, no electrons are emitted. So basically, this means that there is a cap on how much amount of frequency a radiation must have in order for a electron to get into an excited state and just leave the metal surface. So below this frequency, no electron can be emitted. Hence, photoelectric emission can't be carried out. All right. Now, uh, we have another key term, which is the work function energy. And this energy is the minimum amount of energy a photon must have in order to carry out photoelectric emission. Alright, sorry for the writing, but this is another key term, the work function energy. And what this is that is the minimum amount of energy a photon must have in order to carry out photoelectric emission, or in simple terms, the minimum amount of kinetic energy an electron must have in order to escape the metal surface. Because we know that the energy of a photon is transferred over to the electron in the form of its maximum kinetic energy. This is the basic concept of the photoelectric effect. So we've covered the first point, the second point, and the third point. All right. Now we're going to be moving on to the formulas. Just give me a minute. Okay, so in the last class, we went through a formula, and this formula was the energy of a photon. Energy of a photon is equals to Planck's constant into the speed of light divided by the wavelength of the photon, and we derived this formula from it. E is equals to HF. So this is the formula being used over here. So basically what we can derive from this is that the energy is equals to the work function energy and the sum of the electron's energy. I forgot to add the symbol over here. So this symbol is of the work function energy, and this is our formula over here. E is equals to work function energy plus the maximum kinetic energy of the electron. This is our formula over here. All right. So now let's go over the observations from this experiment uh, that provide evidence for the particular nature of electromagnetic radiation. Because as we discussed in the first class, we know that electromagnetic radiation has a wave nature, but we must also know that it has a particular nature as well. So this is the basic or the main concept of this chapter. We are going to be diving into the particular nature of electromagnetic radiation, and this experiment proves it. How? Let's go over it. So increasing frequency at constant intensity decreases the rate of emission of electrons. So this means that when you keep the intensity of the incident electromagnetic radiation constant and increase the frequency, you get less electrons emitted from the metal surface. The second observation is that if electrons are emitted, they are emitted instantaneously without any time delay, and this proves the existence of threshold frequency. Increasing frequency at constant intensity increases the maximum kinetic energy of electrons. So this is our main point over here. Increasing frequency at constant intensity increases the maximum kinetic energy of electrons. Now, why is that? Let's go over this. Because, as I've told you guys before, the energy of a photon, oops, the energy of a photon is equal to uh, this formula right here. All right, the work function energy plus the maximum kinetic energy of the electron. Now, this formula was given to us previously, and we can see that E is equals to HF. And if E increases, where H is our Planck constant, F must also increase as they are directly proportional. So at constant intensity of the incident electromagnetic radiation, if our frequency is being increased, then of course our uh, kinetic energy over here of the electron must also increase. So this is the main factor over here. And what this is basically trying to tell us is that frequency of the electromagnetic radiation is the main factor for the energy of the electrons. All right. And this is constant over here. This is also going to be, the mass is going to be constant. Velocity is going to increase, obviously. And the frequency is going to be increasing, where h is our Planck's constant. So these are the variable factors over here. Let me just write these down. Uh, M. All right. Yeah, so this was it. This was the second topic of this chapter. We have covered this formula and why uh, and the reasons and the observations from the experiment that provide evidence of the particular nature of electromagnetic radiation. So hope you guys understood. Let's go over a basic recap. When electromagnetic radiation is incident on a surface, on a metal surface, electrons are emitted off the surface. And why is that? Because they absorb energy from the each electron absorbs energy from each photon. They get into an excited state and they get maximum kinetic energy enough to leave the metal surface. Observations: frequency is a main factor for the emission of electrons. The higher the frequency, the more kinetic energy of the electrons. All right, threshold frequency, the least frequency needed. And there's another term, the threshold wavelength, and that is basically the longest wavelength needed to carry out photoelectric emission. Work function energy, the minimum amount of energy a photon, meaning the electromagnetic radiation, must have in order to carry out this experiment. And then we went over these formulas. All right. So in the next video, we're going to be covering another topic, the third topic of this chapter. And yeah, I'll be seeing you guys in the next one.